Welcome to the fifth lesson of this course. In this lesson, we will see how to use SQL queries to retrieve data from different tables of a large databases containing clinical information. Data will be analyzed to evaluate the relation among information contained in different tables. You will see how this is done and the possibilities that are offered by this procedure. As done in the previous lesson, we are using the software Microsoft SQL Management Studio. We have already uploaded a clinical database that we have named DBRC. The database consists of 4 different tables, as represented here, and are represented on the left in the menu. The first table contains patient data. The second contains data about medical visits. The third one contains the results of blood analysis tests, and the last table contains the results of urine analysis tests. Let's see now the different data contained in the first table on patient data. We can see that tables are related by primary keys, that are fields that uniquely identify every record in a certain table. The primary key in the table patient data is the fiscal code. This allows the identification of all the visits stored for a given patient. For each visit of a given patient, using the primary key visit ID in the visit table, it is possible to identify the data stored in that visit for blood as well as for urine analysis. Let's now inspect the data in the first table, the table name patient data. As done before, using the SQL query select, we can see all data contained in the table. We see here the first part of the dataset. We can read the different fields, such as the fiscal code, the date of birth, sex, and age. There are several patient data in this table. We can see how many by scrolling down the table, as shown in the next slide. If we go down in the last part of the table, we can read that the total number of patients is equal to 758, as indicated by this red arrow. This dataset refers to an hypothetical population of patients affected by renal diseases. We then have data related to the medical visits, as well as laboratory tests of blood and urine for this large patient population. Let's see now in the next slide which is the number of visits contained in the entire database. To this aim, we can select all the fields in the visit table, as done by the query reported in the top of the window. By scrolling the table down to the end, the number of visits we can read in the table is rather large. Is about 26,000 visits. This number is due to the large number of visits that are present in average for each patient in the database. Actually, the idea here is that patients that are chronically affected by organ dysfunction, in this case the kidney, are followed by the specialist for several years, with several visits and laboratory tests for blood and urine. Let's see now how we can join 2 tables of this database. We would like to create a set of data containing the information about the visits and the patient data at the same time. Let's suppose that we would like to calculate the age of a patient at the time of the visit. We would need to know the patient date of birth and the date of the visit. These 2 dates are contained in 2 different tables. For this task, we can use the SQL query inner join, as reported here, This allows to join the information of the two tables. The result is shown in the table here. This allows to select all the columns of the table patient data on the left and all the columns of the table visits on the right. From this joint view, we can see that a single patient has 16 visits, as highlighted here in the blue area. Since the visits table contains a large amount of data, let's see the end of this dataset. Scrolling down the table to the bottom, as done previously, we can see the last rows. We have lower number of rows of the table visits seen before, since not all the patients in the visits table are contained in the patient data table. Once again, we have several visits for each patient, as highlighted in the blue area. Let's see now if we can make the simple calculation about data present in these two different tables. Let's calculate the age of the patient at the time of a visit. We must calculate patient age, calculating the difference between visit date and the date of birth of individual patients. In order to calculate patient age at the time of the visit, we can use another SQL query, as shown here. After the use of the inner join query between the table patient data and the table visits, we can calculate the difference between the date of birth and the date of a visit with the second query that contains the statement date diff, and we calculated the new field age. The result is obtained and represented here in the second table, where the time difference is calculated in years and the value is named age.